In this video, we are going to learn about discharging of capacitor. That is, initially the capacitor is fully charged. We are going to study how the discharging characteristics looks like. So initially we have a capacitor. This capacitor is fully charged, and Q naught is the maximum charge of this capacitor. That is, when capacitor was fully charged, Q naught is the max value of the charge. Now what we are going to do, we are connecting this capacitor to a resistor. We are connecting a fully charged capacitor to a resistor. This is C and this is R. Now what happens? The current flows like this in the circuit, and the capacitor start discharging, and the energy is dissipated across the resistor. And Q naught is the maximum value of the fully charged capacitor, and V naught is the voltage of a fully charged capacitor. Now let's draw the characteristics curves. With respect to time, what happens to the charge? This is charge versus time. At this point, the capacitor, what is the max value of the charge? Q naught. So, with respect to time, the charge is decaying exponentially. Exponentially it is decreasing or exponentially decaying. If charge is decaying, what about the voltage? Voltage across the capacitor? VC. VC versus time. So this also we get a similar curve. With respect to time, voltage also exponentially decay. So what is the max value of the voltage? That is V naught. What about the current? Circuit current also is a similar pattern decreasing, that is I T. The circuit current also decaying exponentially. Here it is going to be I naught. What about the voltage across resistor? This time on the y-axis, what is there? A VR, voltage across the resistor. So here the circuit current is decaying exponentially. So voltage across the resistor also decays exponentially. So all are decaying exponentially. This is the V naught max value. Whatever the okay. Now let's see how this behavior is. If you write the equation for the previous diagram you have seen, we will represent the voltage of a capacitor in time domain as Vt equal to V naught e to the power minus T upon Rc. Minus T upon Rc. This equation represents the discharging of capacitor. Discharging of voltage across a capacitor. How the voltage is varying with respect to time in a capacitor during discharge. That is what this equation gives. This is the discharge equation for voltage. Now here this RC is known as the let me write it here. here RC, in this equation RC equal to tau. This is the time constant of the circuit, time constant. Let us assume that in the previous circuit what we had, one capacitor and series resistor, RC circuit. So let R equal to 1 mega ohm and C equal to 1 microfarad. What is the time constant tau equal to RC equal to what? 1 meg, that is 10 to the power 6 multiplied by 1 multiplied by 10 to the power minus 6. So this is cancelled, we will get 1 second. So 1 second is the time constant of the RC circuit. RC circuit means we have a resistor, a capacitor in series. So 1 second we got as the time constant if resistance equal to 1 meg and capacitance equal to 1 microfarad. Now let us focus on the, now I think I'll use on the next page here. Now I will draw the voltage curve. Oh, sorry. Let me take the straight line. This and all I can draw it and keep it, but it doesn't help you much because we learn through our senses, so we have to watch and listen. Okay. Now this is the capacitor voltage versus time curve. So exponentially decayed. Okay. So now at one time constant what happens? Now I'll mark it here. This is 1 tau. This is 2 tau, 2 time constant. 3 tau, 3 time constant. 4 tau, and this is 5 tau. 5 time constants, and it goes on 6 tau, 7 tau. Now at first, when the time constant is time equal to 1 time constant, this is 2 time constant. At this point, it is with respect to 1 time constant, what was the maximum voltage we had in the capacitor? Let me write it. That is, V0 was the maximum voltage. So with 1 time constant, how much voltage reduces? It is 0.368 times V0. That much voltage reduces. So during discharging, the time taken by the capacitor voltage to reduce to 36.8% of the fully charged voltage is known as the 1 time constant during discharge. And one more time constant, if the 2 tau, it reduces to 0.135 V0. Again with 3 tau what happens? It reduces to 0.050 of V0. That means 5%. So like that, at 5 tau what happens? 5 tau it reduces to 0.007 times of V0. That means for all practical applications what we do, this phi time constant, we will take it as V0 no Vc. Vc equal to 0. So after 5 time constants, the capacitor doesn't draw any current. No, not. It doesn't have any current to supply during discharge. Now we will see, to make our knowledge a little thorough, we'll try to write a table. This is the time and the voltage across the capacitor Vt. Okay, let me write it as Vc. No, Vt only we have to write, because we have a capacitor equation, right? With the one time constant, one tau, after one time period, what happens? How much the voltage is? That is 0.368 of V0. That means 36.8% of V0. With the two time constant, what happens? It reduces to 13.5% of V0. After 3 time constant, what happens? It reduces to 5% of V0. After 4 time constants, what happens? It reduces to 0.018%. 18. That means 1.8% of V0. Finally, after 5 time constants, it reduces to 0.07%. 0.7% of V0. So after 5 time constant, there is no charge with the capacitor practically. So for all electronic calculations, we use this 5 tau. After 5 tau, capacitor charge equal to 0, almost 0, voltage also 0, current also almost 0. Now, how I am writing this 0.368 and all? How you understood? We had what was the equation we had? Let me write it in the next slide. What was the equation for capacitor discharge? V of t equals V0 e to the power minus t upon RC. This is the equation. Now, one time though I have to calculate. What I will do? V0 e to the power. What is one time though? That is RC. Instead of t, I will put RC. What I'll upon RC. This is equal to V0 e to the power minus 1. What is e to the power minus 1? That is V0 multiplied by e to the power minus 1 equal to 0.368. See, like this I am calculating for the previous table. So now, this is the basic idea about the capacitor discharging. I am not going in detail how the capacitor charges, discharges, all those things. This is reasonably sufficient for us. Okay, now one more thing. What the RC is the time constant. So if by increasing R or C, we can increase the time constant. Okay. So I hope this video was useful to you. If you like the video, please share with your friends and don't forget to hit the like button.